Hello viewers, now discuss on testing of hypothesis. Hypothesis is a conjecture or proposition whose validity is to be examined on the basis of observations. A statistical hypothesis is an assertion regarding the statistical distribution of the population or with a statement regarding the parameters of the population and it is denoted by H. For example, the hypothesis may be the population has mean mu equal to 50 or another example that the population is normally distributed with mean mu equal to 50 and standard deviation equal to 2. A simple hypothesis. If a hypothesis is concerning the population completely such as functional form or and parameter, then it is called a simple hypothesis. Example for simple hypothesis, the statement that the population is normal with mean 25 and standard deviation 10 is a simple hypothesis since the population is completely specified. To give another example, if x follows Poisson with parameter lambda, if a hypothesis is that lambda equal to 2 is a simple hypothesis. Whereas composite hypothesis is a statistical hypothesis, if the parameters are not specified exactly, then it is said to be a composite hypothesis. For example, the statement population follows normal distribution with mean equal to 50 is a composite hypothesis since only one parameter is specified and the other parameter, namely standard deviation, is not specified. Further, in testing procedure, we come across two statistical hypotheses, namely null hypothesis and alternative hypothesis. Null hypothesis, which is being tested for possible rejection, and it is called a null hypothesis and it is denoted by H naught, or else it is a hypothesis of no difference between the parameters involved. For example, if you want to test the average IQ of students of college A is more than average IQ of students of college B, then we might formulate the null hypothesis as H naught mu A equal to mu B, or else mu A minus mu naught B is equal to 0. That is, there is no difference in the average IQ of students. To give another example, if we want to test the yield of paddy in locality 1 is less than yield of paddy in another locality 2, then we might formulate the null hypothesis as H naught mu 1 equal to mu 2, or else H naught as mu 1 minus mu 2 equal to 0. That is, there is no difference in the average yield of paddy in two localities. Alternative hypothesis. On the other hand, the hypothesis which is accepted when the null hypothesis is rejected is called an alternative hypothesis and it is denoted by H1, or else it is a complementary hypothesis to the null hypothesis. Test statistic. A test statistic is a statistic based on the whose distribution testing is conducted. It is defined as relevant statistic minus hypothetical parameter divided by standard error of the relevant statistic. Errors involved in the testing of hypothesis. If a statistical hypothesis is tested, we may get the following possibilities. Actual fact is H naught is true and the decision based on the sample is accept H naught, then it is a correct decision. On the other hand, if the actual fact is H naught is true but we are rejecting H naught, then it is a wrong decision and we call it as type 1 error. Third option, H naught is not true but we accept H naught, again we are committing an error, wrong decision, and this is called type 2 error. Fourth option, H naught is not true and we are rejecting H naught, it is the correct decision. So, we come across two types of error here. One is rejecting H naught when H naught is true, accepting H naught when H naught is not true. In the above table, there are two situations involving wrong decisions. They are called type 1 and type 2 errors. Type 1 error is nothing but rejecting H0 whenever H0 is actually true, whereas type 2 error is accepting H0 whenever H0 is not actually true. For example, in testing the efficiency of a drug, we accept that the drug is effective and safe when in fact it is not so. So, we are accepting a false hypothesis, so it is a type 2 error. Level of significance. It is the maximum probability set by the experimenter for committing type 1 error, and it is denoted by alpha. Alpha is denoted by maximum probability of committing type 1 error. Alpha is known as producer's risk, as well as the level of significance is fixed at 5% or 1%. Size of the test. The level actually achieved by the experimenter is size of the test. Power of the test is defined as probability of rejecting H0 whenever it is actually not true, and it is denoted by 1 minus beta, that is probability of rejecting H0 when H0 is not true, that is 1 minus probability of accepting H0 when H0 is not true, that is nothing but 1 minus probability of committing type 2 error, that is 1 minus beta, is known as consumer's risk as well. Test procedure. It is a rule which, when the sample values have been obtained, leads to a decision to accept H0 or reject H0. From a population having many samples of the sample size n can be drawn. From a population we can draw sample of size n. Let S be the test statistic of all such samples of size n that can be drawn from the population. Then S is called a sample space which tests while testing a null hypothesis among the samples which belongs to S. Some samples lead to the acceptance of H0, whereas some other leads to the rejection of H0. The set of all samples belonging to the sample space which leads to the rejection of null hypothesis is called critical region or rejection region. The value of test statistic which separates the critical region and the acceptance region is called a critical value, and it is usually referred as K or Z alpha. A constant value depends on the level of significance used, that is either at 5% or at 1%. For large sample test alpha equal to 5%, we have K value or a critical value as 1.96. At 1% level, its value is 2.58. The following diagram shows the acceptance and rejection region at 5% level of significance for two-tailed test.